So this is section 6.2, Rational Exponents. In order to use rational exponents, you have to know the rules of exponents. So I'm going to do a little review here. A to the 0 is 1, except for 0 to the 0, which we don't do. Okay. A to the 1 is just A. A to the n times n is A to the n plus m. You can think of n and m don't have to be integers, but just pretend for a moment that they're positive integers and they're counting the number of factors of A. So A cubed times A to the 4th would be 3 factors of A times another 4 factors of A. And so how many do you have altogether? You have 7. So you're adding those numbers. So if you forget the rule, just think of some integers like that, 2 and 3, something like that. And see what you would do there, and then that's what you do with all real numbers. Okay, division is you just subtract. So think of A to the 5th over A cubed. You get A squared because 3 of them cancel. So it's almost like you're taking away 3 factors from the 5, right? A to the 5th over A cubed. So it's always n minus m, regardless of what real numbers n and m are, and regardless of whether m is larger than n or smaller than n. Okay, a to the minus n is a to the 1 over a to the n, and 1 over a to the minus n is a to the n. So if you look at that carefully, you'll see that what it's saying is basically if you move a to the n from the denominator to the numerator, that's this first one, right? Denominator to numerator, because that's over 1, right? The sign of the exponent changes signs. The exponent changes signs, right? And if you move something from the denominator to the numerator, it changes signs. So moving something from the denominator to the numerator changes signs, and moving something from the numerator to the denominator changes signs. Right? You can read this either way. That's all those rules say. And then this is the one where you multiply the exponents. You always think of like, okay, a squared. You know, if you have a squared here, cubed, that would be a squared times a squared times a squared. You'd add the 3 2's together and you'd get 6, right? 2 times 3. This one is there's 2 different bases. That's this part here with the same exponent. Then you can, this isn't distributive. Distributive property is multiplication over addition. This is power over multiplication. It looks somewhat similar though. You have to raise each factor to the nth power. And it works right to left as well. You have to know all these left to right and right to left. So if I have this, 2 different bases but the same exponent, I can put the bases together. And it's the same thing with division. It's not too surprising. So we use those a lot, so you need to be very comfortable with those. Make sure that you know all of those before you move on with any of the rest of this. And if you have to go back to an earlier section, probably somewhere in chapter 1, and find, even if they weren't assigned, find some things with these powers and some practice, and do the practice, because you can't do this stuff unless you know how to do the powers. And same with a lot of problems in the course, actually. So we notice that square root of a raised to the nth power is a. This is just the definition of the nth root. I meant nth root, sorry. The nth root of a raised to the nth power is a. It's a definition of the nth root. The nth root of a is the number that if you multiply it by itself n times, you get a, which is exactly what this says. You're taking this here, and you're multiplying it by itself n times. And so you get the radicand a. That's just the definition. As long as a is greater than or equal to 0. If it's less than 0, you get a bunch of complex weirdness, complex number weirdness, and we're not worrying about that. If n is odd, then you don't have to have this condition that a is positive, because like the cube root of a negative number is just a negative number. Cube root of -8 is -2, for example. So odd n is behaves more nicely than the nth root. I just jumped way ahead. Having problems here today. Okay, but also a to the 1 over n to the nth power is also equal to a. Okay, so it looks kind of suspicious. It looks like maybe the nth root of a is the same thing as a to the 1 over n, and it turns out that that's true when n's an integer, 2 or larger. So we can conclude that, okay? That's just an observation. That's not, it's not a complete proof or anything. That's just noticing that either one of those numbers, if you raise them to the nth power, you get a. So that means that if I raise the nth root of a to the nth power, m power, then I get a to the 1 over n, right? Because the nth root of a is 1 over n. So like, for example, square root of a is a to the 1/2. Cube root of a is a to the 1/3. Fourth root of a is 1 over a to the 1 over 4, etc., right? And if I raise that to the m power, like there, then the rule here, right here, says that I'll multiply those two. So I get a to the m over n. If a is greater than or equal to 0, or if n is odd. So if n is even, then we need this a greater than or equal to 0. If n is odd, then we don't need that. So you only need one of these two. Okay? And that means that if I have a to the m over n, I can write it as the nth root of a to the m. The denominator becomes the root. It's the index of the root, or the index of the radical, if you want, right? And the numerator becomes the power. So you have to remember that. That's super important. If you forget that, then you get lots of problems wrong. So make a note of that. Okay, I can do this the other way around. I can put the a to the m inside. See, the thing inside here is the nth root of a. The thing inside here is a to the m. Raise that to the 1 over n power, and that's a to the m over n. It's the same thing, see? So we could write this either this way or this way. And honestly, this is more common because this way we don't have to write parentheses. It's just less to write. So we kind of like this one better. Plus this one, it's easier to reduce if it reduces. If m is greater than or equal to n, then this reduces, because you'd have a to the n times something else, a to another power, right? Okay, and it's the same conditions here. So in summary, just to summarize this, first of all, know all those rules of exponents. Have them down cold. Don't get them mixed up. Okay? The nth root of a is the same thing as a to the 1 over n for real numbers, as long as our conditions are met, as long as we're not doing the square root of a negative or something. And the nth root of a to the m is the same thing as the nth root of a parentheses to the m is the same thing as a to the m over n. So those last two, we're just using this rule, this other starred rule here for these. All of these are important. All of them are important. We'll use them constantly. Okay. But the starred one is the one that gives us this. Because we're actually multiplying m times 1 over n, right? 1 over n instead of n.